angle work that is in this activity. This activity we highlighted on the previous page, the habits of mind. This is related to the learning goal using construction tools to duplicate an angle. In question 2, it says construct an angle that is twice the measure of angle A. And we're going to do it as an opportunity to practice that construction problem. Here are the steps that we followed along the way. So a little reminder, or flip back a page, or however you're going to handle it, okay? So number 1, it says construct, let me get it right, construct a starter line. So use a straight edge to construct a starter line, label point C. Construct an arc. We have to do one arc, then we have to do a second arc that's the same, like spread out where the angles cross. And then last of all, we're going to copy that arc back to where we're supposed to duplicate the angle and draw a ray through it. Now in our lesson, right, in the lesson here on page 234, the easiest thing to do right now is to just keep this angle here. Now, I'm second guessing myself in this moment. We're going to go from scratch. We're going to duplicate that angle. And I know that if I draw this a little bit longer, I can even use my protractor just to kind of measure it and check that my measurements let me know I've got something that is a certain size. So line it up. A lines up. The black line lines up. I've got a 55-degree angle. 55 times 2 makes 110. So I'm going to actually be constructing a 110-degree angle if I did it right. Okay. Step 1, draw a starter line. So I'm going to draw that starter line down here. I'm going to put my point. In fact, I'm going to make it be a ray. I just automatically know I'm making an angle. This is going to be my C center of vertex of that angle. Now, in order to duplicate the angle, I'm going to do this twice, and then I'm going to erase the line in the middle. So for the first one, after I draw the starter line and I label the vertex, now I'm going to take my compass. Let's use the school compass. I'm going to take my compass, and I'm going to put the center of my compass on A, over here, the original. And I'm going to maybe I'll just use that hole right there. That's right there at the end. So I push the compass all the way into A, and I'm going to use the second hole out here. It's at approximately 3.9 centimeters. So lightly, without shifting anything, make an arc. And then I'm going to actually make one long arc. I know this is not a very big arc, but I'm going to make 2 of them. Oh, seriously, these are like straight trash, but we're using them because we're using them. Because I said so. Okay. Legit support shout out. This is not even like, is it spinning? See, I'm trying to let you know I experience your problems. It's not even spinning. I'm going to tear this page out. Let's go, all of you. All right, we'll slip this one back in. Maybe if I actually remove the paper from the book. Is that going to, yeah, that'll work. Okay, the book was getting in the way. All right, here we go. Yeah, that's much smoother. Okay, tear the paper out. That's what you got to do. Or find some fresh scratch and use that. Now, is that appropriate to say? I don't know. Now, let's see here. So step 3 says I'm going to create an arc that's this big. It starts at the center over here, and it crosses right up here on the other angle, the other ray of the original angle. So using the compass, the center of the compass goes on one of the points, and I'm going to have to maybe like open the compass up. These are annoying. This is what I do to open it up. Kind of like slide it a little bit. Try not to make that horrible noise where it's like a satisfying noise because it's like going ring, ring, and you got like don't do that. That like totally gums it up. It's a horrible thing to do. Okay? Why would you do that to yourself and to other people around you? Now, I put the center of the compass where the first arc crosses the ray of angle A, and I put this hole on the span of the compass out here where the arc crosses the other ray of angle A. So lining it up, checking that I'm in the right spot. I made a little arc just to be like, yeah, dude, you got it right. I'm going to take that. I'm going to go all the way over to here, and I'm going to make a little arc mark. Now, you know what? I don't even need to draw step 4. I'm just going to do this one more time. I'm going to do this one more time because I'm going to make a second angle. I'm duplicating the angle twice. Literally, this is where the duplication step happens. Now I'm going to make a little mark over here. Boom, boom. This is the F, the end point of the angles. I've got an end point here, and I've got an end point or a point on the ray out there. Now, you notice what I did, right? I did one arc, and then I moved it, and I made a second arc off of that first one. That's the key thing. You're duplicating an angle because the distance between the center of my compass and this span hole on the compass is capturing a spread right here. It's like I could just straight up measure it. I could be like, that's about 3.8 centimeters. And then I could go along my arc and I could figure out where 3.8 centimeters hits and then do it a second time. No, 3.8 centimeters. And because I do that, I'm able to actually draw a ray like so. And here's a 110 degree angle. Look at that, money. 110 is 2 times the size of 55. All right. How is duplicating an angle similar to duplicating a line segment? I mean, I've kind of hinted at it. When you use the compass, when you use the compass, you set the radius of the circle and keep using that radius. That's really what's happening, right? The compass creates circles. And since the compass creates circles, once you set this span out a certain distance and keep using it, it's like it's your measuring device. We're not measuring in inches, we're not measuring in centimeters, we're measuring in the radius of whatever circle that you're creating. In the getting started, you constructed an equilateral triangle, ABC. That's what we did on page 232. Duplicating the 60-degree angle shown to construct 5, it says duplicate, not duplicating. Let's duplicate the 60-degree angle shown to construct 5 additional equilateral triangles that share the circle's center as a vertex. All right? By the way, test question. Highlight number 4. This is a test question. Okay? We'll leave it at that. Here we go. So the duplicate happens in step 3. It's where I set my span and I move my span. I'm going to keep doing that. So I need to be very careful with these things and measure correctly, accurately measure the radius. Get it? Oh, these are terrible. These are so terrible. I should just switch to using this thing. This is so much better. Okay. I've captured my radius. You have to do that. You have to move the center of the compass to A. Here, look right down the camera hole right there. The center of the compass is on A. The span hole of the compass is out here on B. And then I'm just going to go and make arc marks around the edge of the circle. There is a mark. There's a mark. There's a mark. Make sure you have a sharp pencil. There's a mark. And then if it worked, if I did it right, I should be actually putting mark and hole in the same spot. And look at that, I line up exactly perfectly with C. Compass, perfection. I'm sorry I talk so bad about you. Now, this is the thing though. We're gonna construct 5 equilateral triangles. So let's bring in that straight edge. And the straight edge is gonna connect center to the edge. Center to the marks that we made. So mark it right there. Center to the edge. Here we go. Mark that. And then last of all, yeah, we're still in the camera. Mark that. See, connect it. Now I did it that way because I'm asking you, or the question's asking you, what shape pops up? What is it that I'm creating? And I hope you know your geometry words from when you were like 5 and learned about shapes, right? Because that's how life is. We learn about shapes when we're little so that in high school you can get destroyed with your understanding or lack of understanding with those shapes. What shape is that? You better say hexagon because it's got 6 sides. Even more so, this is a regular hexagon. And it's a regular hexagon because it's an equilateral, all the sides. It has equilateral sides. It has equiangular because all sides are equal. You thought that was only for squares, didn't you? Well, you were wrong. Because all angles are equal. You thought only squares had all the angles equal. Again, you thought wrong. This is page 234. Thank you for watching. Turn to the next page, next activity 2. Thanks for watching. Stick around for more. Bye.